Just a quick review of what we did up till now in this chapter. Initially, we covered the topic of principle of impulse and momentum, which states that the initial momentum of a particle plus sum of all the impulses that are acting on the particle from time t1 to t2 should be equal to the final momentum of a particle. Then in the next topic, which is the conservation of momentum principle, we considered the interaction between two particles. Since the conservation of momentum principle is always applied when two particles interact or collide with each other. Once you are applying this conservation of momentum principle, the condition for applying this principle is that there should not be any external impulsive force acting on the system during that interaction. So in whatever direction there is no external impulsive force, you can apply this conservation of momentum principle along that axis. This principle states that the initial momentum of the system should be equal to the final momentum of the system, provided that there is no external impulsive force acting on the system along that axis during that interaction. Now this conservation of momentum principle, as we have already said, that it is applied when two particles collide or interact, and you need to draw the free body diagram of the system. While drawing the free body diagram of the system, it should be noted that all those forces which are internal to the system should have a net effect of zero, because they occur in equal and opposite collinear pairs as per Newton's third law of motion. So those internal forces will have a net effect of zero, and therefore they should not be included in our impulse and momentum analysis. Moreover, there are going to be some forces which are producing a very small amount of impulse, such as the weight or the force of an elastic spring. So they should also be neglected while considering the impulse and momentum analysis. इसके मुकाबले में you need to consider only impulsive forces, that is forces which create large amount of impulse in your impulse and momentum analysis. We did solve a few examples and problems relevant to this topic in our yesterday's class. Today, inshallah, we are going to start with the impact analysis. Now, all those problems which we have considered during our previous topic of conservation of momentum were of the form that once these two particles interact, after interaction, they are going to combine together and they are going to move with a common velocity. That is, we did not consider the rebounding of particles after the interaction. Rather, we considered that after interaction, these two particles are going to combine together and the whole system is going to move with a common velocity. However, in actual practice, we can observe that once two particles collide, then after collision, they are going to rebound in different directions with different velocities. So that topic is going to be covered in this impact analysis, which we are going to start today. Okay, so starting with today's topic, which is impact. First of all, let us discuss the definition of impact, the types of impact, and then we will focus on central impact in today's lecture. So impact occurs when two bodies collide with each other during a very short interval of time, causing relatively large impulsive forces to be exerted between the bodies. So impact हम कब कहते हैं? Impact occurs when two particles or two rigid bodies collide with each other during a very short interval of time, thereby causing relatively large impulsive forces to be exerted between the bodies. For example, the striking of hammer and a nail. जब भी आप hammer और nail को strike करते हैं तो क्या होता है कि hammer nail को strike करने के बाद it is going to rebound back. So the striking of hammer and nail or golf club and ball or bat and ball are common examples of impact loading. So these are the examples of impact loading. Now there are two types of impact. The first one is central impact, which we are going to focus today. The other one is oblique impact, which inshallah we are going to cover in next week's class. So what is the difference between central and oblique impact? Let us first of all discuss the definitions, and then we will derive some mathematics relevant to central impact. Okay, central impact occurs when the direction of motion of mass centers of the two colliding particles is along a line passing through the mass centers of these two particles. This line is termed as the line of impact. However, when the motion of one or both of these particles is at an angle with respect to that line of impact, the impact is then termed as oblique impact. These are the two figures which shows examples of central or oblique impact. Let us discuss these definitions one by one. I hope that a blank slide is visible to all of you.
Yes, sir.
Yes, sir.
Okay, now in order to differentiate between central and oblique impact, let us consider a particle, say this particle which is particle A, and it is traveling with some velocity, say VA1 towards the right. Then we have another particle, say particle B, which is traveling towards the left with a velocity of say VB1 towards the left. Since these two particles are traveling opposite to each other, that is towards each other, so definitely they are going to collide at some stage. Now during collision, what would be the scenario? This would be the scenario when these two particles are going to collide. This is particle A, this is particle B. So at the time of collision, you join the mass centers of these two particles. So these are the two mass centers shown to you. So once you join the mass centers of these two particles, you are going to get a line which is termed as the line of impact. So जब भी आपसे कहा जाए कि what is the line of impact? So line of impact is basically an axis or a line which can be obtained by joining the mass centers of the two colliding particles at the time of collision. At the time of collision, आप इनके mass centers से join करेंगे तो जो भी line आपको मिलेगी, that line is basically termed as the line of impact. इसके मुकाबले में जो second axis है या जो second line है, it is defined as the plane of contact. वो plane of contact क्या होता है? The plane of contact is basically an axis or the line which is defined perpendicular to the line of impact at the time of collision. So ये वाली जो आपको यहाँ y axis के तौर पे शो की जा रही है, this is basically the plane of contact. तो सबसे पहली बात तो ये कि इन दोनों लाइंस को समझना बहुत इंपॉर्टेंट है, बिकॉज इन्हीं लाइंस की बेसिस पे आपके इम्पैक्ट की डेफिनेशंस और इम्पैक्ट की एनालिसिस जो है वो की जाती है. तो मैं दोबारा रिपीट कर देता हूँ. व्हाट इज द लाइन ऑफ इम्पैक्ट? द लाइन ऑफ इम्पैक्ट इज बेसिकली एन एक्सिस व्हिच वी कैन ऑब्टेन बाय जॉइनिंग द mass centers of the two colliding particles at the time of impact. At the time of collision. So line of impact आपको इस तरह मिल जाएगी. The plane of contact which is defined to be an axis that is drawn perpendicular to the line of impact at the time of collision. So ये आपके पास plane of contact आ जाएगा. Okay, now how you are going to differentiate between central and oblique impact, because the procedure for analysis of both types of impact is different from each other. So first of all, you need to identify कि ये जो impact हो रहा है ये किस कैटेगरी में आता है, और फिर उसी हिसाब से उसकी मैथमेटिक्स, उसकी इक्वेशंस जो है वो हम अप्लाई कर सकते हैं. ओके, नाउ व्हाट इज सेंट्रल इम्पैक्ट? सेंट्रल इम्पैक्ट की अगर हम डेफिनेशन देखें तो सेंट्रल इम्पैक्ट की डेफिनेशन क्या कहती है कि इफ बोथ these particles were traveling along the line of impact before collision, then that particular type of impact is termed as central impact. यानी central impact से क्या मुराद है कि collision से पहले अगर ये दोनों particles इसी line of impact के along travel कर रहे थे, यानी इनका momentum इसी line of impact के along था, तो then that type of collision is basically termed as central impact. Central impact की definition हर एक को clear हो गई है?
Yes, sir.
Okay, so just a quick review कि central impact क्या होता है? It is an impact in which both the colliding particles were traveling along the line of impact before collision. इसके मुकाबले में अगर हम oblique impact की बात करें तो oblique impact क्या होता है? When one or both these particles are traveling with respect to the line of impact at some angle, then that particular type of impact is termed as oblique impact. For example, मैं आपसे कहता हूं कि आपके पास particle A जो है, it was not traveling from the position shown to you earlier. Rather, this particle A was located at this position and it was traveling at a velocity VA1 at an angle of say θ1 with respect to the line of impact. At the time of collision, आपने जब line of impact बनाई तो वो यही blue वाली line बनी थी. Since particle A has a velocity which is at an angle with respect to the line of impact, so basically now this type of impact would be called oblique impact. इसी तरह अगर मैं particle B की बात करूं, मैं कहूं कि particle B जो है वो instead of traveling from this location, let us say that this particle B was located at this location and it was traveling with a velocity VB1 at an angle of say phi1 with respect to the line of impact. So at the time of collision, this is the line of impact which is shown to you by the blue line. Since now both these particles are traveling at an angle with respect to the line of impact before collision, so it is an example of oblique impact. तो oblique impact में एक या दोनों पार्टिकल्स लाइन ऑफ इम्पैक्ट के along ट्रेवल करने के बजाय किसी एंगल पे लाइन ऑफ इम्पैक्ट से जो है वो कोलिजन से पहले ट्रेवल कर रहे होते हैं, so that particular type of impact is termed as oblique impact. I hope that now the definition of central and oblique impact are clear to all of you.
Yes, sir.
Yes, sir.
Okay. So in case of central impact, since the particles were traveling along the line of impact before collision, so after collision भी ये line of impact के along ही जो है वो travel करते हैं. So rebound होंगे या collide होने के बाद line of impact के along ही travel करेंगे. If you are considering the case of central impact, it means that the number of unknowns which are involved in a case of central impact are the magnitudes of final velocities. Initial collision से पहले वाली velocities आपको known होती हैं. So there are just two unknowns which are the magnitudes of final velocities after impact. However, in case of oblique impact, न सिर्फ इनकी velocities unknown होती हैं बल्कि इनके collision के बाद वाले angles भी unknown होते हैं. So the number of unknowns are going to be 4. That's why the procedure for analysis of central and oblique impact is different from each other, because in case of central impact you are going to have two unknowns, that is the magnitude of final velocities, whereas in case of oblique impact not only the magnitudes of final velocities are unknown to you, but the angles or the direction of these velocities are also unknown to you. So overall, you are going to have 4 unknowns in case of oblique impact. It means that you require 4 equations in order to find out those 4 unknowns. Okay, now let us consider another simple example in which I say that you have a horizontal surface as shown to you here, and then you have a particle which is, say, particle A, which is traveling towards the right, as we have discussed earlier as well, and you have an identical particle which is particle B, which is traveling towards the left as shown to you. Now once these two particles collide, so once A collides with B, what would be the case? Is it a case of central impact or oblique impact?
Central impact.
If the particles are identical, then it would be a case of central impact. However, if I say that this particle A is in the shape of a sphere having a radius of, say, RA, and then you have another particle which is particle B, which is shown to you here. This particle B has a radius of RB, which is, say, different than RA. That is, you have two unidentical particles as shown to you in the figure. Now, once these two particles collide, what should be the case now? Is it a case of central impact or oblique impact now?
Sir, central impact, क्योंकि
now this is going to be the line of impact, isn't it? The blue line which I have shown by joining the mass centers. So since both the particles were traveling along this line of impact?
No, sir.
So now if you have two particles which are not identical to each other and they are going to collide, then it would become a case of oblique impact rather than central impact. ठीक है? तो आपके पास situation को देखते हुए you need to first of all identify the type of impact. Is it a case of central impact or is it a case of oblique impact? And based upon that definition, आप फिर उसकी analysis करते हैं, because if it is a case of central impact, then you need to apply the procedure for analysis of central impact. If it is a case of oblique impact, then the procedure is going to be different. So first of all, based upon the figure, you need to identify is it a case of central impact or oblique impact, so that you can accordingly apply the correct procedure for analysis of that problem. Is this point clear to all of you?